Okay, in this video we're gonna show you a capacitance board. What is a capacitance board? It's a board that lets you choose a certain capacitor value you would like to use in a circuit. So that maybe for some reason you play around and see if you find one that would work well with a circuit you're designing or something like that. We need to choose a capacitor. You don't know which one. This is very simple and easy. We use dip switches here, surface mount ones. I use don't have to be surface mount ones to be regular ones. I use surface mount ones because they go well with the copper tape and are easy to solder to when there's only just 2 pins on each side of it, and then the other side all is tied together like that for grounding it. Or ground, connecting the one lead the capacitor to another. Another thing you don't want to do, like I did, is see this cord here. You don't want to use no coax cord. That gives capacitance and adds more capacitance onto it. This is because it's just like the capacitor design. It's like an insulator surrounding another metal plate. It's taking the center of the plate right there, like that bare wire there and that white wire, surrounded by that other bare wire wrapped around it to shield it from getting radio wave frequencies. And however, it'll protect radio waves, but then again, it'll add resistor and add capacitance onto it. But the capacitance is not that big. I have all of them off. I'll show it to you how big the capacitance is. It's only like 126 picofarads. Well, the sure which is how they're going to refine. As long as the thing is one it way messes up with, because this is close. This one here is supposed to be 4.3 nanofarads. It comes out to 5 or 6 when it's hooked to that cord. It comes out 5 on it without it, but it'll come up around 6 with it to the cord. This is so probably what you'll want to do when you design it. Don't design it with a coax cord. Design it with just regular wire, regular 2 wires. So let's get started. First, you'll see in the circuit here. There's switches here. For each digit, they go like this: 1, 2, 4, and 8. Now, 8 is usually something you're not gonna be able to find. You can make it simply 8 out of a 3.3 of it, of that digit, plus a 4.7 of that digit. You add those two together, it'll give you 8. That's how you get the 8th of it, the 8 value selected. These dip switches work pretty well. You probably don't want to use a 50 volt or higher power source project, because otherwise you'll be trying to flick these switches and you get shocked. So to prevent that from happening, don't use it in anything that's 50 volts or higher. It was pretty easy to solder to. I tested it out. Oh, of course, some parts of the time I got them all soldered out and I had to test them, and someone wasn't making contact. So I thought I had contact and it didn't, and I had to resolder it. Then there was one of them I had close together and they were touching, so I had to take something and scrape it off to break the connection between the 2 tapes in the solder joint. Like right there, you can see. So let's begin. So let's show you what it does. I have it in a 2000 picofarad range. So if I to go from 1 nanofarad, it's 1,000 picofarads. Well, very close to it, 1,121, which is good. We're gonna go to 2. We'll wait for it. Hang on. 2 nanofarads, or 2.31 nanofarads. You went over 2,000 picofarads since 1 picofarad, 2 picofarads equals to 2,000 picofarads. Now, I mean, 2 nanofarads are equal to 2,000 picofarads. And it went over it because it's a .30. So that's why it said it was over. It was overloaded. Then next we're gonna do is we're gonna look at is that zoomed in on there. Range switch. Let's do 3. Both 1 and 2 up. As you see there, 1 plus 2 gives you 3. Of course, this just adds those 2 up together to give you whatever it's going to be, plus the coax cord. Next, if you do 4, we get 5. But this is because that it was giving me like 6 point something. This 5, no wonder it gives you 6 sometimes. It's close to it. It's real close to it. 5.9 is real close to 6. These capacitors have very large tolerances than what a regular resistor would have. So probably getting a certain value or something would be easier to get on a resistor than it would be on a capacitor. Because the tolerances are high. Usually on electrolytic ones, the high is like 10 or 20%. That's plus or minus 20%. So if you take this one down, we'll go to 6. Maybe next, no, not 6. It'll go to. Let's go show you 6. I'll do 6, not 8. 5, and then 4 plus 1 will be 5. Well, of course, it's 6 on there. Then if I do 4 plus 2, it gives us 6. It gives us 7. It gives 8. That's closer to 8 than it is with the other one, I think. 6, 7, 8, 9. Then finally I'm gonna go to 10. Close to 11 there. 10, 11, 12, or 13, 13, or 14, 15, or 17. Wait, am I right? 5 plus 1, 4 plus 1 is 7, is 15, or 17. 16 is 18 there. Sometimes the capacitors get off the out of range just because they're not that best. You probably could spend a lot more money on getting more high precision ones, and then it'll be a lot better. But this should be pretty enough. Also, this meter here, since it was a cheap one from Amazon, it's probably not 100% correct what it's reading. Since this one came from Amazon, I think this one also came from China. I'm not sure. Because there's no brand on it. It just says 4070. And I had this for a long time. And I did put a new battery in it. Because I never used it in a while. And then when I turned it on, the battery symbol went up on it, showed up on it. So I decided to go get a battery for it before I make this video. So it's good with the accurate I can get. Let's see what I get for this time. 17, which is supposed to be 15. Yeah. No, 16. 17. It's just 19. Now we're at 25 nanofarads. Yeah, up to 25 nanofarads. So as you see, I'm doing these switches here. It adjusts the capacitance on there. What's pretty neat about this is that sometimes it's going to be hard to find a variable capacitor that can go in nanofarads, a few nanofarads. Even if you want to do 100 nanofarads, it's going to be hard to find one. Because basically, all the variable capacitors you're going to find are made for radio tuning circuits out of tuning stations in it. And those they're usually real low on capacitance, like only a few picofarads, and that's it. Very low capacitance there at all. You can do the same thing with resistors. How you do it with resistors? Very simple. Instead of it going from, well, instead of having you get rid of this part here, you'd have one would have the wire coming from the last one to there, and then you'd have a resistor going across each one, like that. Go from here to there, there to there, from each part of that switch there. Because then once you flip the switch, it'll bypass that resistor and short it out, and it'll be disabling that value. Because it'll be a direct short. You can do the same thing with inductors that way. If you want to do an inductor substitution board. But I like the capacitor one because it's just a lot easier. I could have probably did resistor one, but it'd be hard doing power ones, but they're so big. You can design this for any decade up to whatever number you want to do. In fact, you may think that it can go up to like what, like 9. It can go pretty high. I'll show you how high it'll go. I'll put on the 2 microfarad. It'll go up to like at least a microfarad or so. Now the switches turn on. And this switch right here, it goes to the 4 digit on the last one, the 400s. It doesn't work. I think what happened is when I was trying to solder it there, I actually heated the switch up too much, and it must have moved something inside it. It could have moved something, and it could have made it when you flip that switch, it's not touching it. But the other one on the other side works, because I tested it. And I even tested it by like measuring from here to there, not from there to there, and it worked. So it's telling me that this switch here is the problem. I might, next time when I order some of the West Florida components, I might order another dip switch to put on there to get that capacitor working. And so right now I got it fully turned on every single switch except for of course this one's not working. So what do we get for the result? It's out at 1.388 microfarads. So it's basically go up to 1 microfarad on it. A little bit above that. But it'd be amazing if you go higher on it. Let's say you went to the hundreds, you could get 1,000 microfarads and so on. This is because when you with those 4 digits, the 1, 2, 4, and 8, if you add all of them together, that gives you 15.
Who are you talking to? You doing a YouTube video?
Yeah. It makes 15 of it. Which is actually a 2-digit number. 1.5. Of course, it's probably this meter here, kind of off or something, giving us 1.389. Oh yeah, not only that, the capacitors are not probably all that collecting the same value exactly. It's probably a few less than what was expected. And there you have it. Capacitance substitution box. Very simple circuit that you can build. This is building a floor wall tile, the extra pieces that were left over that's the person that need to use, that cut it off of it. And it works pretty well. In a vinyl too, which is just exactly the same kind of insulator as electric tape is made out of. So it has good insulation properties. So it's probably good for up to 600 volts or so, I bet. I don't know if I really want to try it that high, because that's what usually the copper, the electric tape would say. It may not be. The electric tape might be some specially made vinyl. Because last time I looked out in the garage where they had these floor wood tiles, that said it was vinyl. And that's what they exactly say on electric tape, it's vinyl. It's probably the soft, stretchy one. So, there you go. An easy project to make using your very first. This is a good thing to do if you want to try out surface mount switch soldering. And it wasn't that hard. Surface mount stuff it's not that hard if it depends on how many pins it has, and how you gotta wire them, and how big the thing is. If it's so tiny, like a tiny resistor, it's gonna be too hard. But but we know these dip switches, they have to be big, because they gotta be made so you can toggle it. They can't go so tiny that your fingers can't toggle the switch. So basically, they'll work pretty well, even a surface mount whatever not. I like surface mount ways because they can go with the copper tape. Now if you're doing a regular circuit board with holes on it, you have to get the through hole one, the dip one package. Well, that's it for now. So I hope you enjoyed this video. So thanks for watching. If you like it,